Hello, the question says translate the following statements into chemical reactions and then balance them. So first we need to write a chemical equation and then we need to balance the same. So the first equation is first reaction is hydrogen gas combines with nitrogen to form ammonia. Second reaction is hydrogen sulphide gas burns in air to give water and sulfur dioxide. Third one is barium chloride reacts with aluminium sulphate to give aluminium chloride and a precipitate of barium sulphate. Part D or last part is potassium metal reacts with water to give potassium hydroxide and hydrogen gas. Let us look into this one by one. The first part is hydrogen gas combines with nitrogen. So we have here nitrogen, that is N2. It combines with hydrogen, that is H2, to form ammonia. The formula for ammonia is NH3. Now in this equation, in the left hand side we have two nitrogens, but in the right hand side we have only one. So first we will balance the nitrogen. So if we balance the nitrogen, it will become 2NH3. So if we write 2NH3, then hydrogen becomes 6 hydrogen. So let's put 3 this side. Now let's count the number of atoms again. So there are 2 nitrogens in the left hand side, 2 nitrogens in the right hand side. There are 6 hydrogen in the left hand side and 6 hydrogen in the right hand side. Therefore this equation is balanced. Now part B, hydrogen sulphide gas. So we have hydrogen sulphide, that is the formula for hydrogen sulphide is H2S. Hydrogen sulphide gas burns in air. Air means oxygen. Burns in air to give water and sulfur dioxide. So the products are water. Water means H2O and sulfur dioxide, that is SO2. Now let's balance this. The number of, let's start with hydrogen. So number of hydrogen on left hand and right hand are equal. Then sulfur, number of sulfur on left hand is equal to number of sulfur on right hand. Now what is not equal is this oxygen. So let's balance the oxygen here. So there are 3 oxygens in the right hand side, so there should be 3 oxygens in the left hand side. So simply we can write it this way. We need 3, right? But there are 2 oxygen together, so I can write it 3 by 2. Okay, now since 3 by 2 is not a whole number, we have to make this 3 by 2 as a whole number. Now how to make 3 by 2 as a whole number? To make 3 by 2 as a whole number, we multiply 2 on both left hand and right hand side. So if we multiply 2, it becomes 2H2S. Now 3 by 2, we have to multiply 2 here again. So if you multiply 3 by 2 and 2, you will get 3. So this will become 3O2. And in the right hand side, we have 2H2O plus 2SO2. Now let's count the number of atoms. So number of hydrogen on the left hand side is 4. Number of hydrogen on the right hand side is also 4. Number of sulfur on the left hand side is 2. And number of sulfur on the right hand side is also 2. The number of oxygen in the left hand side is 6. Therefore number of oxygen in the right hand side is also 6. Okay, so therefore this equation is balanced. Now let's move to the third part. Part C. So part C says barium chloride. Barium chloride. The formula for barium chloride is BaCl2. Barium chloride reacts with aluminium sulphate. Aluminium sulphate, the formula for aluminium sulphate will be Al2SO4 3. Aluminium sulphate to give aluminium chloride. Now aluminium chloride formula is AlCl3 and a precipitate of barium sulphate. Precipitate of barium sulphate. Formula for barium sulphate is BaSO4. Precipitate means it's a solid formation. Just show it with an arrow downwards. Okay, now let's balance this equation. Let's start with barium. Okay, so number of barium on the left hand side is 1, number of barium on the right hand side is also 1. Number of chlorine in the left hand side is 2, but the number of chlorine in the right hand side is 3. So what we have to do is we have to multiply this with 2 by 3. We have multiplied it 2 by 3 just to make the number of chlorine on both the sides of the equation as equal. Okay, so we have multiplied it with 2 by 3, but 2 by 3 is not a whole number. So what we have to do is we have to make it a whole number first. So what we do is we multiply 3 on both left and right hand side so that 2 by 3 becomes a whole number. So if we multiply 3 here, we get 3 BaCl2, we have then 3 Al2SO4 3, then this 2 by 3 multiplied with 3, it will become 2. 3 will cancel and we are left with 2, and then this will become 3 times BaSO4. Now let's count the number of atoms again. So barium is balanced and chlorine is balanced. Now let's move on to aluminium. Number of aluminium on this left hand side is 6, but the number of aluminium on the right hand side is 2. So we have to balance this number of aluminium. So to balance this number of aluminium, what we have to do is we simply have to multiply so 2 and 3. So simply we have to multiply it with the LCM of 2 and 3 is 6. So we have to multiply 2 with 3. So if we multiply 2 with 3, we get this as 6. Now to get this as 6, and this is also 6, so aluminium on both the sides is balanced. Alright, but again okay, so aluminium we have balanced, but again just look at here. Now how many chlorines are there on the right hand side? The number of chlorine has changed from 6 to 18. So number of chlorine on the right hand side is 18, but number of chlorine on the left hand side is only how much? Only 6. So we have to make the chlorine equal. So if we equal the chlorine, then it becomes we have to make it 18, right? So we have to multiply it with 9. Is it okay? Okay, yeah. So we have to multiply it with 9. So chlorine is balanced, but look at barium again. This time barium become how much? There are 9 barium. So what you do is you have to make this 9. So you will multiply it with 3. You will multiply it with 3. So if you multiply it with 3 again, you get you have to multiply with 9. Okay, sorry. So you have to write it as 9 barium sulphate. Alright, now you see we have 9 barium on the right hand side, but what about the sulphate atoms? You see on the left hand side you have sulphate SO4. Total number of SO4 on the left hand side is 3 times 3, that is 9, and total number of sulphate on the right hand side is again 9. So in this way we have balanced the sulphate atom as well. You see, this is a tedious process. This is a trial and error process. So you have to do again and again so that you get to the final answer. So one thing you have to keep in mind is you should always check the number of atoms on each step so that you don't commit any mistake. So if you look at it again, so number of barium on the left hand side, is 9. Number of chlorine on the left hand side is 18. Number of barium on the left hand side is 9, and number of chlorine on the right hand side is 18. Similarly, number of aluminium on the left hand side is 6, and number of aluminium on the right hand side is also 6. Number of sulphate atoms on the left hand side is 9. and number of sulfate atoms on the right hand side is also 9. Therefore this equation is balanced. It is a little bit tricky and little bit tough at the initial stage, but once with practice you will develop very good habit of solving this kind of questions. So part D, let's move on to part D. Part D says potassium metal reacts with water to give potassium hydroxide and hydrogen gas. So potassium metal symbol is K. It reacts with water, that is H2O, to form potassium hydroxide. Potassium hydroxide is KOH and hydrogen gas. So this is your H2. Okay. Now we have to balance this. So how to balance? Potassium. Okay. So potassium is balanced. Very good. We have to move to H2O. So number of H on the left hand side is 2 and number of H on the right hand side is 3. So we have to make this equal. Okay, so let's balance the H2 first, right? Okay. So we have to multiply. There are 3 hydrogen on the right hand side and 2 hydrogen on the left hand side. So we have to take the LCM of these two. So LCM of 2 and 3 is nothing but 6. So we have to make 6 hydrogen on the left hand side. So we multiply it with 3. So it becomes 3H2O. Okay, so we have to multiply 6 here. So we multiply again. We have to make it 6, right? So this is 3, this is 2. Okay, so if we make it 4, then hydrogen becomes 4 and this is 2. So total 6. So left hand side we have 6 hydrogen, right hand side we have 6 hydrogen. Now let's count the number of oxygen. Number of oxygen on the left hand side. So hydrogen is balanced. So let's move on to the next one. So let's count the number of oxygen now. So number of oxygen on the left hand side is 3, but number of oxygen on the right hand side is 4. So we have to make these two equal. Now the LCM of 3 and 4 is 12. So we have to make it 12. Okay. So what we do is we have to make 12 oxygen on the left hand side. So we multiply this with 12. Now we have 12 oxygen on the left hand side. What about the number of oxygen in the right hand side? So we have to multiply 12 here also. So if we multiply it with 12, we get 12O. So basically here we have balanced the oxygen, but what about again the number of hydrogen? You see here, number of hydrogen on the left hand side is 24, and number of hydrogen on the right hand side is your 14. So you have to make this two equal. So we do one thing, this is 24, this is 12, so we multiply this with 6. Now 6 to 12, and this is 12, total 24. Now let's focus on the, so number of hydrogen on the left hand side is 24 and number of hydrogen on the right hand side is also 24. Now let's balance the final element, that is potassium. Number of potassium on the right hand side is 12. So the number of potassium on left hand side should also be 12. So this is the balanced chemical equation. Just look at equation number C and equation number D again. What can we see is, in equation number C we have 9, 3, 6, 9. From 9, 3, 6, 9, can we not take 3 as LCM here? Yes, we can take 3 common from both, not LCM, 3 as common from both left and right hand side. So if we take common 3 from left hand side as well as right hand side and cancel one another, then what we have is, for equation number C I am saying, so I am taking 3 out here. So this will become 3, this will become your, just let me do this way, let me cross it. Okay. So this is the original equation. Now we are taking 3 common. So if we take out 3 common from here, we are left with 3, this is 1, this is 2, and this is again 3. So if we simplify this equation, then we will have The simplified expression then we will have is simplified expression will be 3 1 2 3, and just remove this superscripts. Okay, fine. Okay, so this is the balance equation. Similarly in this part D, look at here. So you can take 6 common, right? So this is 2, this is again 2, this is again 2, and this is again your 3. So this expression D can be simplified to 2 potassium, can be simplified to 2 potassium, 2 water molecule, 2 KOH and 3 H2. So this is the simplified expression. Now if you again count the number of atoms, then you will find, let's see on for equation C. For equation C, let's see, number of barium on the left hand side is 3, number of barium on the right hand side is also 3, number of chlorine on the left hand side is 6, number of chlorine on the right hand side is also 6, number of aluminium on the left hand side is 2, number of aluminium on the right hand side is 2, number of sulphate molecules on the left hand side is 3, number of sulphate molecules on the right hand side is also 3. So therefore equation C is balanced. Similarly equation D, in equation D you see number of potassium on the left hand side is 2, number of potassium on the right hand side is also 2, number of hydrogen on the left hand side is 4, number of hydrogen, okay, so we have committed some mistake. Let me check. Okay, so we have committed one mistake. The mistake here is this should not be 3, but this should be 1. This should be a 1. Okay, so now if we simplify this, we have 2 2 2 1. So let's count the number of atoms again. So number of potassium on the left hand side is 2, number of potassium on the right hand side is also 2, number of hydrogen on the left hand side is 4, number of hydrogen on the right hand side is also 4, number of oxygen in the left hand side is 2, and number of oxygen in the right hand side is also 2. So basically this kind of question will require you some amount of practice, but it can be done with a proper amount of practice, and you can really be very fluent with this simplification once you practice more and more. So that's all for this question. Thank you.